Isip na Hub.
Welcome to another episode of our series on inferential statistics. In this presentation, I'm going to show you how to conduct a correlation analysis in MS Excel. If you haven't watched yet our presentation on the basic statistical test, I would suggest that you watch that video first before you proceed watching this one. I'm going to put the link for that video in our description below.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
Alright, let us proceed with our problem here. Let me read it first. Explore the relationship between and among the variables below. Describe in test the relationship of problem solving to the other variables. We have 5 variables: problem solving, reading comprehension, mathematics proficiency, score to a test that measure your stress level, and your high school general weighted average. The researcher here is interested of knowing which of the 4 variables here is related to problem solving. So the dependent variable is problem solving, and these 4 variables here are our independent variables. Okay, so if we look at our data here, all of them are true numerical data. So that means the level of measurement here is at least interval, and therefore the appropriate correlation analysis that we should apply is the Pearson product moment correlation coefficient, or simply called the Pearson's R. To compute for the Pearson product moment correlation coefficient, or simply Pearson's R, we use the Excel command equals Pearson, and then we input our data. So it's asking us 2 arrays, array 1 and array 2. This is referring to the 2 variables that we want to correlate. So since this is our first variable, then we input it as is. So we drag and hold, comma, we input our second variable, this variable. We close it with a parenthesis and then enter. It will give us a number that is between -1 and +1 inclusive. It cannot go beyond that number. This is the coefficient describing the relationship of the first pair of variables. Next is we compute the correlation between problem solving, this variable, and the second independent variable, this one. To compute for their correlation, we proceed similarly as we did a while back. So we start with the command equals Pearson, open parenthesis, our first variable, it's this variable, comma, and our third variable, this variable, close parenthesis, and then enter. It will give us again a number that is between -1 and +1. Let me quickly do for the other pairs of the variables that we want to correlate, that is between problem solving and stress, and then the last one, it's between problem solving and high school. In the problem, it's not asking us to correlate these 4 variables here. It is only interested of exploring the relationship of problem solving to the 4 of them. There we have it, our 4 correlation coefficients. The next thing that we should do is how to report these results in our table. So we are going to transfer these values in a table so we could interpret it better. Here is a guide. In this part, we're going to copy the correlation coefficients that we computed a while back. For this part, we are going to give a descriptive equivalent to those Pearson's values. I'm going to explain this one in just a moment. So for the first one, correlation between problem solving and reading comprehension, we have 0. If we round this one up to 2 decimal places, we have 0.58. Let me as well round the other correlation coefficients. Alright, so we have the coefficients. The first one is 0.58. This value. We have the second pair of variables being correlated. The correlation coefficient is 0.82. We have also this one, third pair of variables being correlated, and the last one. So here are our correlation coefficients. Let me organize it first. Now we proceed providing a descriptive equivalent for these numbers so we can interpret them later. I'm going to make use of the lookup function for this one, since I have here in our legends the scale that we use. We start with our equal sign, lookup, and then the absolute value of the Pearson's R. We are going to take the absolute value since we did not indicate here the negative part of the scale. A correlation coefficient could be negative as well. So absolute, the shortcut for absolute is ABS, absolute value of this value, comma, and the reference matrix. So this part here. Close parenthesis. Again, we should not forget to put dollar signs. And then we drag. So there we have it. Our Pearson's R and their descriptive equivalent. We are not yet done since we have to put something here. What does this mean? If we go back to our problem, it asked us to describe and test. What does it mean? The word describe is actually referring to the computation of the correlation coefficient. This word here, test, it's asking us to test that correlation coefficient, whether it is significant or not significantly different from 0. Why do we need to do that? Why do we need to test a correlation coefficient? Is it not that obvious that if the correlation coefficient is high, for example, numbers like 0.5, 0.8, or 0.78, does it automatically mean that it is significantly different from 0 because they are high numbers? Or if the correlation coefficient is low, for example, we have 0.01, 0.02, or even 0.003, does it automatically mean that it is not significantly, this is supposed to be not significantly different from 0? The answer is no. We need to test this coefficient because if in our test, our p-value is greater than 0.05, it means that the correlation coefficient is not significantly different from 0, or it is equal to 0. And if it's equal to 0, then our interpretation is this one. If this is just the same as 0, then we cannot really say that the correlation is moderate, but the correlation is actually none. There is no correlation. Well, for most cases, if we have a high correlation, we have also a low probability value. That means that this correlation coefficient is significantly different from 0, so we can actually interpret this one as is. Or for a correlation coefficient that is really low, normally when we test it, our probability value will be really higher than 0.05. That means that it's not significantly different from 0. So this is just 0 that is very weak or no correlation at all. So how do we test? We look for, let's try to look for Pearson R p-value calculator. Let's see what appears. I think we can use this one. So if we click this one, it will ask us our R score. R score is the Pearson's R that we computed earlier, and N is referring to the sample size or the number of observation or the number of pairs included in the analysis. So we go back in our Excel, we copy the first correlation, so this one, let's copy that one and paste it here. Okay, and then our N, let's count the number of observations, number of pairs. So we have how many students? We have 17 pairs. So let's put here 17, and then we can just leave this one. Our alpha is 0.05, and then let's calculate. This is the result. The p-value is this one, 0.014747, and of course that is less than 0.5. Let us round this number into 2 decimal places, so that is 0.01. Let's put it here, 0.01. Let's do the same for the other correlation coefficient. Let us solve for the p-values. Of course, the sample size will not change, only the correlation coefficient. So this is the second coefficient. Let's copy this one and paste it here. Let's calculate. Our second p-value is 0.0000057, or if we round it up to 2 decimal places, that is just the same as 0.00. For our third coefficient, the answer is again 0.000036, or that's just the same as 0.00. Where's the last one? Calculate. The p-value is a high number. It's 0.88097, or that is just the same as 0.81. We are now done with the computation of p-values. It's now time to interpret our results. Let's start with our first correlation between problem solving and reading comprehension. The correlation is 0.58, and descriptively that is a moderate correlation. Also, the p-value is actually less than 0.05. This means that the correlation coefficient is significantly different from 0, and that is good because this descriptive equivalent here can be interpreted meaningfully. So what does it mean? Our Pearson's R is positive and it's moderate. This means that the correlation between problem solving and reading comprehension is moderate. If the score in problem solving increases, there is a moderate tendency that the score of that student also increases in reading comprehension. Our interpretation is vice versa. How about the second pair of variables, problem solving and mathematics proficiency? The correlation is very strong. So how do we interpret this one? It is also positive and it is significant, meaning it is significantly different from 0. It's actually even higher than the first correlation. This means that if the problem solving score of a student increases, the tendency for its mathematics proficiency is to also increase, and the chance of that happening is very strong. Also, if the mathematics proficiency of a student decreases, the tendency for its problem-solving score will also decrease. It's a two-way relationship. How about the third one? It's negative 0.83. That is still very strong, and it is significantly different from 0. The difference with this correlation coefficient now is negative. So how do we interpret a negative correlation? The relationship is inverse. And what do we mean by an inverse relationship? If the stress level of a student will increase, the tendency for the scores of the students under that problem-solving test will decrease. So it's negative. So while this is increasing, it is increasing. The problem-solving score is decreasing. If this is decreasing, the tendency for the student's problem-solving score will increase. That's what we mean by an inverse relationship. It is going the other way. For the last correlation between problem solving and the high school general weighted average, the score is really low. It's 0.06. When we tested it, if it's significantly different from 0 or not, the answer lies on the value of the probability result. It's greater than 0.05. This means that the coefficient is indeed equal to 0. And 0 Pearson's R means that the two variables are not correlated at all. High school general weighted average has nothing to do with problem solving. And that is because maybe this performance was a long time ago, it doesn't really reflect how those students are doing today compared to the other factors here. Just to show you a scenario where the correlation is high but it is not significantly different from 0. I have here a data set. I only have 3 observations, so there are only 3 students here. Let us try to correlate this one. Equals Pearson. The value is really high. It's 0.86, and 0.86 correlation is descriptively very strong. However, if we're going to take that coefficient so that we would know the corresponding probability value. Remember, the number of observation is 3 because there are only 3 students. If we put it here, we change this 3 and calculate for the corresponding probability value, it would give us, what's that, 0.34. That is 0.34, and this is greater than 0.05. This means that although this is a very high number, it is not significantly different from 0. So we will treat this not as a high correlation but equal to 0. There is actually no correlation between this one, and the main reason for this one is our very small sample size. So you see that even if the correlation coefficient is very high, the corresponding probability value could be really high, indicating that correlation coefficient is not significantly different from 0. So we would still conclude that there is not enough evidence that these two variables are significantly correlated. So there we have it, correlations. Thank you for listening.